This is part 2 of section 2.5. We've gone through what I call our library of functions. We learned 7 different basic functions and their graphs. And now we're going to talk about how to transform them. When we do this, we have to follow this order. We have to do our horizontal shift first. So we'll look at our equations once we know how to identify things, and we'll move our graph either left or right. Now, stretch or shrink, I don't really cover this part. It does appear in the homework, but you will always be able to find the answer based on steps 1, 3, and 4 and not have to worry so much about 2. What this does is it will make our graph maybe where our quadratic look like this mainly. Now maybe it looks more like this. But we will still be able to tell whether it's been moved left or right, whether it's been flipped over the y-axis or the x-axis or moved up and down. So we're not going to have to worry so much about that. Once we take care of any horizontal shift, then we flip it however we're supposed to, and we're going to be talking about this, and then we move it up and down. Okay, so the first thing I'm going to talk about is a vertical shift, and I have this labeled an outside, and that's going to make a lot more sense after we get to compare it to an inside. Okay, what this says is the graph of a new function is equal to f of x plus k. So we're going to have one of our 7 functions here, maybe an x squared, and then we have either added or subtracted some number to the outside of that function, okay? If we have something like this, where just a number is either added or subtracted at the end, then our graph is going to have the same shape as the original, but it's going to be moved up k units if it's a positive number, and we're going to move it down k units if it's a negative number. So if we look at this right here, our base function is x squared. So I am going to be using our basic quadratic function, okay? This is on the outside. It is a positive 2. So I'm going to take x squared and move it up 2 units. Okay? Now this was our quadratic, and I'm placing it right here with what we call right here, this is our vertex. You place the vertex at 0, 0, and I actually marked all 4 corners of my grid so I can make sure it was lined up properly. And then I'm going to take this whole thing and move it up 2. 1, 2. Make a note of where your new lines are. Okay, so I'm going to be placing points here, here, and here. Here, here, and here. And then you can mark the others if you want to do it that way. You can mark them up here, or you can just basically draw in the basic shape. It doesn't have to be perfect. And we know basically what our new graph is going to look like. Okay, if you can recognize it as a quadratic function, knowing it's going to have this basic parabola shape, there's a number added to the outside, so it's going to be going up that many units. And we have our answer. Okay, so let's try this one. F of x is equal to x squared minus 1. My basic graph is going to be my quadratic again. I'm going to start off with my x squared graph, which is the parabola. And there's a number on the outside, and this time it's negative, so I'm going to take this graph and I'm going to move it down, because that's a negative, 1 unit. Okay, so if this is my basic graph, I'm going to take this whole thing and move it down 1. So I'm going to place these 5 points appropriately. So here, 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 and here. Make sure that lines up. Yes, and then you draw your new graph, and you can see that it has the same shape as the parabola, and that's not a pretty curve there, but I'm not pretending to be an artist. And you have your new graph. Okay, so let's talk about a horizontal shift, which I call an inside. Notice between here and the previous page, here the difference, the added number is outside of the function. The whole function is written here, and then a plus k or a minus k is on the outside. For here, the change is inside of the function. That's what I mean when I call this an inside. Okay, The graph of f of x is equal to f of x minus h. has the same shape as the graph of f of x. So if this looks overall to be a square function, a quadratic, then it's still going to have that basic shape. But it's just going to be either moved to the right or to the left. Okay. Now, the thing is with a horizontal shift is it seems completely backward. And it has everything to do with the fact that that formula has a minus sign in the middle. Okay. So let's just compare this to this before I go through the rest of this. It looks like I have a square function. So I'm going to have a basic quadratic here. If I compare this to this, I have x minus, what is my h value? My h is positive 2 because this has a minus in it, this has a minus in it. If my h is a negative 2, then this is going to end up being minus a negative or a plus. So my h is a positive number. If your h is greater than 0, then you go to the right 2 units. So I'm going to take this graph and I'm going to move it right 2 units. Okay. So if this is my basic quadratic and I move it right 2 units, that's what it's going to look like. Okay. So draw your points. And then connect your graph in a smooth curve, or as smooth as you can manage. Okay. Now this one has a plus inside. It's inside the square, so I'm still starting off with the square. If this had been a cube right here, I'd be starting off with a basic cubic function, but I'm starting off with a square. This time it's a plus. So my h value is -1 because this negative is going to make a double negative here, which gives me the plus. So I'm going to go left 1 unit. So I start off with my basic quadratic and I move it to the left 1. So graph your 5 points and then connect them with as smooth a curve as you can. Okay. All right, so let's consider reflections or flips, okay? If you see a negative involved, you're going to be flipping your graph either across the x-axis or across the y-axis, depending on where the negative is. Here, the negative is on the outside of the function. It's not inside the parentheses here. It's outside. And if it's on the outside, then it's going to have the same shape of f of x, but is going to be reflected or flipped over the x-axis. So what I mean by that is if my graph initially looks like this, and I go to flip it across the x-axis, it becomes this. Okay. Now, recall the order we had to do things in first. Our order is that we have to do a horizontal shift first. And then either stretch or shrink the way, but we're not doing that, and then reflect. Then vertical. And this one has multiple parts to it. I see I have a negative here, and I have a change in my square right here. Okay, so I know I'm starting off with my basic quadratic. So this is my basic shape of my graph. It's just a matter of how it's moved, how it's flipped, everything else. Okay. I have a change of a 1 inside of the square, so this is going to be a horizontal shift. Remember, horizontal shifts seem backwards. This is a minus sign, so my h is a positive. I'm going to go right 1 unit. Okay. And then I have a negative on the outside of my function. So this is an x-axis flip, which is an up-down flip. Or you can say reflect around x-axis. okay? So if I start off with my basic quadratic here, then I'm going to shift it to the right 1 unit, and then I have to flip it upside down. So my graph should look like this. So that would give me these 5 points, and I have this basic shape.